All right, so on this one, we're supposed to refer back to problem 53. So let's read it first. So problem 53 says, the officers of a high school senior class are planning to rent buses and vans for a class trip. Each bus can transport 40 students, requires 3 chaperones, and costs $1,200 to rent. Each van can transport 8 students, requires 1 chaperone, and costs $100 to rent. Since there are 400 students in the senior class that may be eligible to go on the trip, the officers must plan to accommodate at least 400 students. Since only 36 parents have volunteered to serve as chaperones, the officers must plan to use at most 36 chaperones. How many vehicles of each type should officers rent in order to minimize the transportation costs, and what are the minimal transportation costs? Now, what does it actually say for problem 54? Now, if each van can transport 7 people instead, and there are 35 available chaperones, show that the optimal solution found graphically involves decimals. Find all feasible solutions with integer coordinates and identify the one that minimizes transportation costs. Can this optimal integer solution be obtained by rounding the optimal decimal solution, and explain? Okay, so sounds like we're going to get complicated here. Let's say let's let x equal the bus and y equal the van. And the key here now that is 7 people instead of whatever it was, the eight, I think. Yeah. And the bus is still back up to 40 students, so that's still 40. Okay. And what else do we know? Instead, we have only 35 chaperones instead of 36 in this problem. So what we want to do is we want to minimize, and that's going to be a cost. And what do we want to minimize? Well, we have $1,200 to rent what? The bus. So we have 1,200 times X plus, and the vans are only 100 times Y. So we're minimizing that cost. And it's subject to what? Well, it's subject to. All right, so now we got to make sure we have all the right things. So we have 40 times X plus, now we have 7 times Y, and that has to be what? There's going to be, we have to have at least 400 people, right? Okay. And see, we have to have at least 400, so it has to be greater or equal to 400. And then the last one is the chaperones. And so there's 3 chaperones per bus, so that's going to be 3x plus only one for the van, so that's y. And that has to be less than or equal to, and now we have only 35 and not 36. And x and y have to be greater than equal to 0 because that's just the only way it works. All right, so now we solve. So y is going to be what? Greater than or equal to a minus 40 over 7x plus 400 over 7. Here we have y is less than or equal to minus 3x plus 35. And we still have, of course, our x and y greater than or equal to 0. All right, so graphically, we're just going to draw a rough sketch and then we'll go from there. Let's see, 7 goes into there. So that's going to be 35 is going to be less. So 35 is going to be at a smaller angle. So it's going to come down something like that. This one's going to come down at an angle. That's not a good draw. All right, so now we have this one. Oops, we have this one coming down something like that. And now what we have is the has to be less than the 35, so it has to be less than this but greater than that. So that looks like the only area is really this one right here. So now we need to find those and this one and this one. So when that is 0, that's going to be 10. So that's going to be 10, 0. So 10, 0. And when we plug in 0 here, that's going to be what? 35 fifths. So that's going to be 35 over 35 thirds, 0. And this one we're going to calculate with our calculator. So we'll plug all that in, y equals, and now we'll clear that, clear that, clear that. And so we had what? A minus 40 divided by 7 times x, and then it was plus 400 divided by 7. And our second one was minus 3x, and then plus 35. And so our graph graph looks like that. And with that, like I said, we're in this region here, so let's maybe make our window a little bit different here. So let's make that only, oh, I don't know, 20. Let's go by 5. And let's make that one. That's probably let's make it. Can we do a division in here? Hey, we can. Let's go by 5. So let's go make that one 60, I guess. Be easier. And so that's what it looks like. And so we need to know this here piece. So we need to find that intersection. So 5, and we're gonna doop, doop. And so that's gonna be our thing. 8.158 and 10.526. All right. So let's go back here. So that point was a little longer than what I left room for. It was 8.158 and 10.526. And so now we have to use all three of those points to kind of come up with what the values are going to be. Now, which ones are going to look nice? There's going to be probably just the 10, 0. The others are going to have some kind of weird decimals, it looks like, but that's okay. So our cost is going to be equal to what? Well, it's going to be 1200 times x, which was 10, plus 100 times 0. So that's going to be $12,000. And so that's for this one. So the next one, I guess we can do this one as next. We'll go just round the clock. So that's 1200 times 35 over 3 plus, and then 100 times 0. And so that's gonna be 400 times 30. Let's see. 1200 times 35 divided by that's 14,000. That's what I was thinking, but it wasn't close. And then let's see here. Well, this one, that one is going to be not so nice. So that's going to be 1200 times 8.158 plus 100 times 10.526. And I'm going to do that in my calculator. So that's going to be 1200, oops, 1200 times 8.158 and then plus 100 times 10.526 and I get 10,842.2. Okay. All right. Now, do these make sense? So it says, can optimal integer solutions be obtained by rounding the optimal decimal solutions? Well, these are not going to be making any sense at all because you're not going to be able to get the right X's and Y's. Those are students and I mean buses and vans. Can you have an 8.158 van or a 10.526 van or even the 35 thirds van? Not really. So it doesn't make sense to have partials. So let's write that down. Does not make sense to have partial buses and vans. Okay. And so therefore we're just going to round. Okay. And we're going to round based on up and down. So let's round this one down to 8 and this one up to 11 because that would be kind of how it would be. And so what does that give us? Well, that would give us C equals 1200 times 8 plus 100 times 11. And so that's going to be what, 96 and 1100. So 10,700 it looks like. Okay, so that would be that. And so that would be our value here. Okay. And so now what do we have to do here? Now we have to kind of figure out what is the values, other values. Do we need any other values here that are whole numbers? So actually, we should probably look at it going both ways. Do we need to go both ways? Okay, we don't need to go both ways, but now let's look at this. 8 and 11. 8 and 11. Well, that's going to be outside of here. That's not going to be in here. So what we need to do is we need to get a number that's actually within our feasible solution area. So we have to get a number that's in there. And so what number would be in there? Well, we could do a 9 and a 6, I believe would work. And if we go back to our calculator, let's look and see where that would be, see if we can find it. Do a 1 and plug in a 9. And so and now that's at 5.7. So above that would give us a 6. And so yeah, that's going to work. All right, so 9, 6. Now what would that be? Now that would be 1200 times 9 plus, and that's going to be 600. So that's going to give us 11,400. So that's going to give us a cost equals 11,400. And how many students will be able to go with that? Well, if we take that times 40, so 9 times, oops, 40, and then plus 6 times, so that gives us 402 students can go on the trip. If we have that many buses and that many vans, that would give us 402 students that could go on the trip. So that's more in our 400, so that works. That's going to be basically our minimum cost is the 11,400 because if we look here, that's 12,000, that's 14,000. So we kind of moved that one around to make it sure it was in that region. So 8 and 11, oh, that's not in that region. And so then we had to go down and instead get 9, 6, which was right about in here. That was in a region. And then that gives us our minimum cost of 11,400 for 402 students. All right, so that was one of those complicated problems, but we got through it there. All right, so let's stop there and come back for some more.